Hello everyone. In this video, we are going to see how to sketch Bode magnitude plot and Bode phase plot. This is similar graph sheet where we are going to sketch Bode magnitude plot and Bode phase plot. So for sketching this Bode plot, I have taken a small system with open loop transfer function g of s is equal to k by s into 1 plus 0.001s into 1 plus 0.25s into 1 plus 0.1s. So I have the coordinates of magnitude plot and phase plot readily available. In this video, we are going to see how we are going to sketch the plot, and from the plot how we are going to determine various parameters like phase crossover frequency, gain crossover frequency, phase margin and gain margin. So once you have taken the similar graph sheet, you can notice there are few sections of readings available along the x scale. So x scale here it is logarithmic scale. So you can mark the frequencies starting from 0.1 and 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. And after 1 it is 2, 3, 4, 5, 6, 7, 8, 9, 10. And after 10 we have 20, 30, 40 up to 100. And after 100 it is 200, 300 up to 1000. Then after 1000 it is 2000 up to 10,000. So these are the 5 different sections of similar graph sheet along logarithmic scale. And if you notice along the y scale there are 7 sections. So 7 units are available along y scale. So it is mandatory to know how to choose the scale for your Bode plot. So first let me show you the coordinates of magnitude plot. So for this case, this is the magnitude plot coordinates. So for frequency 0.1, the magnitude is 20 decibels. For 4 radian per second it is minus 12 dB. For 10 it is minus 28. For 1000 it is minus 148. For 2000 it is minus 172. So here if you notice, the maximum decibels in magnitude is plus 20 and minimum it is minus 172. You can take the magnitude plot scale between plus 20 and minus 180 or whatever. So here in this magnitude plot, there are, as I said, there are 7 sections. So here the maximum magnitude is plus 20. So I am going to take the maximum decibels. Here it is 40 plus 40. This particular point 40, and I am going to fix a scale of 1 unit is equal to 40 dB. So this point is 0 dB line, and this one is minus 40, then minus 80, minus 120, minus 160, and then minus 200. So if you observe, I have only one possibility that I can choose 40 dB per unit. If I choose 20 dB per unit, I cannot able to plot the least data, such as I cannot able to plot minus 140 dB. Why? Because I can my similar graph sheet have only 7 sections. So in this way we have to choose the scale. So the scale, first y-axis 1 unit is equal to 40 decibels. So I have written the y scale, and the phase plot coordinate, you can see the phase plot coordinate right over here. So for different frequencies like 0.1 radian per second it is minus 92 degree, 4 it is minus 157, 10 it is minus 203, likewise up to 2000 I have taken. If you notice, the minimum, that is the in negative quadrant, the minimum one is minus 92 degree, and then in the negative quadrant the maximum one is minus 333 degrees. So if I if I fix the scale between 0 degrees and 400 degrees, that is more than enough. And always I used to fix y-axis 1 unit is equal to 100 degrees, right? And this phase plot to be drawn in the lower half of the similar graph sheet. So I want only 4 units like 0, 100, 200, 300 and 400. So let me fix the sections from here. So this is 0 degree, and this one is minus 100 degree, and this one is minus 200, this one is minus 300, and this one is minus 400. So I have taken the scale in this way. So all the coordinates can be possibly placed between these scale. So this is the first foremost job when you start sketching your Bode magnitude plot and Bode phase plot. Then let me show you the reference lines for Bode magnitude plot. The reference line for Bode magnitude plot, it is 0 dB line. So this is that. So first I have to draw the 0 dB line. So that one is drawn. Then the reference line for phase plot, it is minus 180 degree line, and the minus 180 degree line will come over here. So I have drawn the reference line for Bode magnitude plot and Bode phase plot. Then the next job is to fix the sign. So for sign convention, for Bode magnitude plot, above 0 dB line it is negative, and below 0 dB line it is positive. And for phase plot, above minus 180 degree line it is plus, and below minus 180 degree line it is minus. Let me explain you what is the reason for fixing this sign convention while plotting. Now let us plot the magnitude plot coordinates first. So the point 1, so this is how you have to check. So for 0.1 radian, this is the first line, 0.1 radian per second is the frequency, and the corresponding magnitude is 20 decibels, plus 20. So here I have chosen 40 decibels as a unit. So one line takes 4 dB. So I have to start counting from here, 0, then 4, 8, 12, 16 and 20. Exactly at 5th line corresponding to 0.1 radian, I will get the first coordinate. Then at 4, the 4 is up to this, it is 1, then 2, 3, this is 4 radian per second. This line is 4 radian per second. I have to keep my scale along 4 radian per second. Then I have to place this minus 12 dB. So minus 12 dB, it is below 0 dB line. It is, so it is minus 4, minus 8, minus 12. So this point is minus 12 dB. Then the next frequency is 10 radian per second. My 10 radian per second line is this one, and I am going to place my scale along 10 radian per second, and the corresponding coordinate is minus 28. So minus 28, it is minus 4, minus 8, minus 12, minus 16, minus 20, minus 24, minus 28. It will come over here. So I have placed the dot and encircled it. Then the frequency is 1000. So 1000 here, this one is, this line is 100. After 100 it is 200, 300, 400, 500, 600, 700, 800, 900, and this line is 1000 radian per second line. This is the frequency line of 1000 radian per second. I am going to place my scale over here, and the corresponding magnitude is minus 148. So minus 148 will come after minus 120. This point is minus 120. Then minus 124, 128, 132, 136, 140, 144 and 148. This is minus 148, this point corresponding to 1000. And then final coordinate, it is 2000. So I am going to place my scale along 2000 radians. 2000 radian per second frequency I have placed, and the corresponding magnitude is minus 172. So this line, this particular line is minus 160. So minus 160, minus 164, 168, 172. So this is minus 172. So I have placed all the coordinates, and by using your scale, just join all the coordinates. So first I am going to join the first two coordinates exactly at the points. Place your scale joining the 2 points, not the circle. So I have joined the third coordinate with the fourth coordinate, then fourth coordinate with the fifth one. So now my magnitude plot is over. I sketched my magnitude plot. Then the next one is the phase plot. The phase plot coordinates, I have to place my scale along the horizontal axis. So for point 1, first I want to keep minus 92 degrees. So in this phase region, minus 92 I cannot exactly place. Why? Because each line carries 10 degrees. So this one is minus 10, minus 20, minus 30, minus 40, minus 50, minus 60, minus 70, minus 80, minus 90. So this point is minus 90. I cannot able to place minus 92 exactly. So just let me take this is minus 90. So I am going to place my scale along minus 90 degree line. So I kept, and the corresponding frequency, it is 0.1. So 0.1 radian is the first line. So I have plotted my first coordinate. Then the second one is minus 157. So I will take minus 160. Rounded, you just round all the values of phase angle so that it will be easy for you to place the plot. So minus 160 I will take. So this is minus 110, 120, 130, 140, 150, 160. So I want to keep the scale along minus 160. So placing your scale plays a vital role when you are sketching the Bode phase plot. I kept exactly at minus 160 line. Now the corresponding frequency is 4 radian. So up to this it is 1, 2, 3. This line is 4 radian. So corresponding to this line I marked a dot and just encircle it. Then the next angle is minus 203.7. So I cannot able to place minus 203. Let me take minus 200 rounded value. So along minus 200 I kept my scale. And the frequency for 200 it is 10 radian per second. 10 radian per second line is this one. So I have marked. Then similarly the next angle is minus 267. Let me take it is minus 270. So 270 will come over here, this point. So I am going to place my scale along 270 and the corresponding frequency is 100. So 100 point is this one. I have placed. And the next one is 314. So I will take minus 315. This is minus 310. Minus 315 will come between minus 310 and minus 320. So I kept my scale along that particular angle and the frequency is 1000. 1000 line is this one. So exactly I placed. And the last coordinate it is minus 333. So I will take minus 330. Minus 310, 320, 330. This line and the corresponding frequency it is 2000. So 2000 line is this one. So exactly at 2000 radians. So I have placed a dot. Now I have sketched all the coordinates inside the plot, that is phase plot. What we need to do is you just join all the lines, all the coordinates using scale and the pencil. You have to use a pencil of 2H so that it should be very smooth, and we should not use scale for connecting the phase plot coordinates. To have a smooth curve, we should use only freehand diagram to connect all the coordinates. But I am using scale, and just see what I am going to do after this. So I have connected all the coordinates very light. Now I will sketch this over this line. I am going to draw the line using freehand. So this is the Bode magnitude plot and Bode phase plot of the system having transfer function k by s into 1 plus 0.001s into 1 plus 0.25s into 1 plus 0.1s. In the next video, we will see how to determine the phase crossover frequency, gain crossover frequency, phase margin and gain margin. Thank you.